So it looks like we're doing more trig tonight.
Yeah, we have a test on Wednesday, so this is our review packet.
Okay.
So I took pictures of the ones I completed in class, so I just wanted to quickly go over them and see if I'm doing them right. And then I circled a few of them that I wasn't quite sure on.
Okay.
I'll point them out in a second. And then the very last page with like the big graph that I'm supposed to make, I have no idea what I'm doing on that one. So we'll do that one after we review these ones.
All right.
But the first page is
I'm a little confused by this first one, number 3. Oh,
okay.
Okay. You've got this drawing here.
Yeah.
All right. And you say the sine of theta is equal to 6.3 because that's this dimension here.
Yes.
Over 7. Okay. Does your teacher want you to give these in decimal answers, or do they want you to give them in radical form?
He said that like the decimal answers were fine today. So.
Okay, because that's unusual. Usually with trig, you don't do that.
Okay, if it was trig, just in case, what would it be?
You mean if it was radical form?
Yeah, radical, yeah.
All right. The way you do all of these kind of problems is you can do it this way by drawing it in the fourth quadrant, and you know that it's in the fourth quadrant because you have the cosine. Oh, I see. I couldn't read that. That's where you're getting the picture from. So the cosine of theta is 3 over 7. I wasn't saying that until just now.
Oh, okay.
And the sine of theta is less than 0. Well, I'm going to show you my way of doing it, and I think you're going to see that it's easier.
Okay.
Whenever they give you, and this is a classical trig question, where they give you the value of one trig function. In other words, they tell us the cosine of theta equals 3 over 7, and then they say that the sine of theta is less than 0. Well, there's only one quadrant where that's true. There's only one quadrant where cosine is positive and sine is negative, and that's the fourth quadrant. Okay, so we know that much. Now, to solve the rest of it, just draw a right triangle. Doesn't have to be in the fourth quadrant. Just draw a right triangle and label theta. Okay? Now, because they've told us the cosine of theta is 3/7, we can put a 3 there and a 7 there. No matter what fraction they would have given us, if they'd have said 1/2, I had to put a 1 there and a 2 there. Okay? And because we have a right triangle where we now have 2 dimensions, well, this dimension here is the square root of 49 minus 9. So that's the square root of 40, or 2 root 10. That's the more typical way to do these kind of problems, is to leave your answer exact instead of expressing it as a decimal. Now that I have this, and the fact that I know I'm in the fourth quadrant, well, that makes the sine of theta 2 root 10 over 7.
Right, I wrote that in the top.
Right, makes the tangent of, well, actually this is negative 2 root 10 over 7. And in fact, you need to put a negative sign there, because it's telling you that sine of theta is less than 0. So the sign has to be negative. Okay, so that's, regardless of how you express it, it's negative, whether it's 2 root 10 over 7 or 6.3 over 7. Cosecant of theta is the reciprocal of that. So cosecant of theta would be negative, because it has to have the same sign as its reciprocal. In other words, we know that cosecant of theta is also negative in the fourth quadrant. Now, there is one problem with that answer, and what is it?
It's the inverse.
It's got a irrational denominator.
Okay.
Okay? So, there's one advantage in you writing it the way you wrote it, is you don't have to do anything more with that. If that's acceptable to your teacher, well then that's fine.
Okay.
But if your teacher wanted it in radical format, which is more precise, you end up with this, but this has to be rationalized. In other words, I need to multiply this by root 10 over root 10, and what I end up with in the top is 7 root 10, and what I end up with in the bottom is 2 times 10, 20.
Okay.
And it's still negative, so this would be the proper radical answer.
Okay, for sine of theta?
For cosecant. For sine, that's just fine over there. Notice, notice that the sine has the irrational number in the numerator, and it's okay there. You don't have any problem. It's only when it's in the denominator that it becomes problematic. Okay? So I've got the cosecant. Excuse me, I had it for a second there. Let me write it again. I've got the sine. What's the tangent going to be based on my triangle?
The tangent would be...
tangent of theta. And when you draw this triangle, it's very important to label theta, because theta could be this top angle. It doesn't have to be this angle down here. So unless you label it, you don't know really how to do it.
Right. So the tangent of theta would be 6.3 over 3, so opposite over adjacent.
Okay, or in my case, 2 root 10 over 3. And what's the sign on it? Plus or minus?
Wouldn't it be positive?
Negative.
Oh, negative, because it's in the fourth quadrant?
Fourth quadrant. Let's go over that. Here's quadrant 1, 2, 3, 4.
Right.
And what you have to remember is all students take calculus.
Okay.
The A means all trig functions are positive in the first. The S means sine only is positive in the second. And of course, by only, I mean the sine and the cosecant. They both have to have the same plus or minus sign. Any reciprocal has the same plus or minus sign as its reciprocal. Okay? The T means only tangent in the third quadrant, and the C means only cosine in the fourth quadrant. So when this problem gives us a positive cosine and a negative sine, it can only be in the fourth quadrant. That's the only place where that's true.
Okay.
Once you've figured out that it's in the fourth quadrant, you don't really need to draw the reference angle like they're doing. It just confuses the issue to me. In other words, you can solve every one of these problems by drawing your triangle like that.
Okay.
Okay? You just have to know which quadrant you're in. Once you know the quadrant, then you figure you can do it based on this triangle to come up with the proper number, and then you just put a plus or minus sign on it equivalent to the quadrant that it's in.
Okay.
That's why tangent's negative. Okay, they want all 6 trig functions. We know the cosine, we know the sine and the cosecant, so what's the cotangent?
So would you multiply the top and the bottom?
It's just it's the inverse of the tangent.
Okay, so it'd just be 3 over minus 2 root 10.
Negative 3 over
Negative 3.
2 root 10. But again, if you're in decimal, it's fine. But if you're in radical, this needs to be rationalized.
So that'd be negative 3 root 10 over 20.
And that can't be simplified any further. So that's going to be the proper answer for cotangent of theta. Okay. And the only one we didn't do was the secant. What's the secant of theta going to be?
It'd just be 7 over 3.
Yeah, and it's positive because it's fourth quadrant. It has to have the same sign as cosine does.
Okay.
Okay?
All right.
All right.
And then I guess we can just kind of skip around. It doesn't matter what order we go in. But on number 4, I kind of understood it, but not really.
Okay. State the quadrant that when they say the quadrant of the terminal side.
Yeah, we're allowed to use our trig circle on it. So that's how I knew the quadrant.
When theta is 7 pi over 6, that's third quadrant, because this is pi over 2, this is pi, this is 3 pi over 2, and that's 0, or 2 pi. So anything greater than pi but less than 3 pi over 2 is in this third quadrant.
Right. The thing I was messing up on this one was the reference angle and the...
Your reference angle is good. Let's go back to the unit circle again.
So when you're getting, just so I understand this a little more, like when you're getting the reference angle, do you subtract or add 180?
Here's what you have to memorize. In the second quadrant, it's 180 minus theta. In the third quadrant, it's the reverse of that. Theta minus 180. And in the fourth quadrant, instead of 180 minus theta, it's 360 minus theta. Okay? So notice, and instead of 180 minus theta, I can also say pi if I'm in radians.
Okay.
And instead of theta minus 180, I can say theta minus pi. And instead of 360, I'm going to say 2 pi.
Okay.
So memorizing these will allow you to take any angle they give and convert it to a reference angle. Notice that if I'm in the third quadrant here, well, what's 7 pi? I'm doing theta minus pi, so 7 pi over 6 minus pi is pi over 6, which is 30 degrees.
Okay.
So getting the reference angle, you just use one of these formulas depending on which quadrant you're in. Okay, now let's look at number 5 where the angle is negative. You can do two things here. You can work from here and go clockwise 200 degrees, which puts you in the second quadrant.
Oh, so it is in the second quadrant. Okay.
Or you can convert that to a positive angle immediately. Well, the positive angle for minus 200 is plus 160, right? Those are the same thing. Minus 200 and plus 160. And it's easier to actually tell that 160 is in the second quadrant than it is minus 200. So I would always immediately convert that to a positive angle and go from there. Okay? So that's second quadrant. And since it's the second quadrant, we're going to use this formula to come up with the reference angle. 180 minus 160.
Okay.
The reference angle is 20 degrees.
Okay.
And that's another thing that makes it easier if you convert this negative angle to a positive angle, it's real easy to use one of these formulas here to come up with the reference angle.
Okay, so
Notice that if I do 180 minus a negative 200, I get 380,
positive.
but that's a reference angle of 20 also. So it doesn't matter which way you do it, as long as you come up with an acute angle less than 90 degrees. Your reference angle always needs to be the angle less than 90 degrees. In other words, the equivalent first quadrant angle.
Okay.
Now, a coterminal angle, you got it right. You add or subtract 360. The only problem I would have with your answer on 4 was they gave it to you in radians. I would tend to want to keep it in radians. In other words, I would, in number 4, I would go 7 pi over 6 plus, instead of 360, let's do plus 2 pi. Okay, well, 2 pi is 12 pi over 6. So that's 19 pi over 6 is a coterminal angle. Also, 7 pi over 6 minus 2 pi gives you minus 5 pi over 6 is another coterminal angle. So adding or subtracting 2 pi or 360 degrees, if you're in degrees, gives you the coterminal angle. In other words, this one's really easy. We just add 360, so 160 is the coterminal angle.
Okay. So was I right with the angle on number 4?
What is that? 210 plus 360? Yeah.
Okay, and then
in other words,
number
that
5
one is 210.
Okay.
And number 5 is 160 is a coterminal angle.
Okay, sorry. Just to clarify, I got a little confused. The coterminal angle on 4 is 210?
No, that's what 7 pi over 6 is.
Oh, okay.
That's 210.
But,
so if I'm adding 360 to that, I get 570. So your coterminal angle is correct.
Okay.
Okay. You just need to add 360 to that to come up with this one.
Okay. Makes sense. And then number 6, I just want to go over it quickly, and then I was confused on C at the very bottom.
Okay. Well, the amplitude is 6. The period is what, based on the formula?
The period would be 4.
Well, the period is always 2 pi over b.
Okay.
So what is b? b is pi over 12. So 2 pi divided by pi over 12. Flip and multiply. What do you get?
Okay, so flip it. So it'd be 12 over pi?
No, let's do the flip. In other words, when we flip the bottom and multiply, then it becomes 2 pi times 12 over pi. Instead of,
oh, that's what I was saying.
and
Yeah.
the pi's cancel, and you're just left with 24. So your period is 24.
Okay.
Okay? And looks like you're close to the period. Yeah. The period can be measured from any trough to any trough, or any peak to any peak. Well, what we have are troughs here, but looks like the x-coordinate on this trough is -1. So if my period is 24, which it is, then I've got to go 24 units to the right of minus 1, which puts me at 23.
Okay.
So your graph, is that your graph or is that their graph?
That's my graph. I was all convolved,
okay.
but I understood how to graph it.
Let's talk about how we graph it.
Okay.
Once we get the period of 24, now let's talk about the horizontal shift. Well, that's the phase shift. That's C. Only 2 is to the right. In other words, the standard is y equals a sine of b x minus c plus d. And if c is positive, it's to the right. Well, in this case, c is positive.
Okay.
Positive 2. Because the standard is x minus c. And a positive c means a shift to the right.
Okay.
In the same way, remember when we were working with parabolas? Well, there's x squared, which is a parabola at the origin. But if I say y equals x minus 2 quantity squared, this 2 is a shift to the right, meaning my parabola would be like that.
Okay.
Sinusoid functions are no different. And in fact, A, B, C, and D are exactly the same as a vertical stretch, horizontal stretch or shrink, a horizontal shift, and a vertical shift.
Right.
All right. So if we have the period correct of 24, and we have the horizontal shift, which really this should not have a plus or minus, this should say 2 units right.
Okay.
Because the negative isn't clear whether we want to go right or left. And in fact, we want to go to the right, not the left.
Okay.
Vertical shift should say 4 up, not 4 midpoint. We're moving our horizontal line of symmetry, your dotted line here.
Right.
We're moving it up 4. Not the 2, but the 4.
Right.
It should be right there.
Okay.
Now, once you have the amplitude, the period, the horizontal shift, and the vertical shift, you can graph it. And let me show you the way I would graph this. Okay, I've got A equals 6, period equal 24, horizontal shift equal 2 right, vertical shift equals 4 up. So, here's how I'm going to graph it. I'm going to start by going up 4, draw my dotted line. Next, I'm going to go to the right 2 units. This is my starting spot.
Okay.
If it was a sine curve. I'll get back to that for a moment because this is a cosine curve, so I don't start there. But next, I know my period is 24, so I know where I begin and I know where I end. I end at 26.
Okay.
I now quarter that interval up. I break it into quarters. Okay. This is halfway between. So I add 2 plus 26 and divide by 2. That's 14.
Okay.
Now I get halfway in between there. 2 plus 14 is 16. Divided by 2 is 8. Halfway in between there is 20. So I now have my 5 key points on this curve. Where I want to begin is at 2. Where I want to end is at 26. Now I look at amplitude. 6 means my high point is going to be 6 above 4. My high point is going to be at 10. My low point is going to be at -2. 6 below 4. Okay? So, now I know exactly how to graph. I know the cosine starts at the high point. So I'm going to draw a dot. In fact, let me get rid of these x's because I like to use x's as points where I'm going to draw it through. Okay? So I'm going to start my curve right there because I know cosine starts at the high point.
Okay.
Cosine then goes down through the horizontal line of symmetry at the first quarter point. So I got to go down through that point. It goes down and hits its lowest point, -2, at the second quarter point. Comes back up through the line of symmetry at the third quarter point and ends at the same place you started. And now connect the dots. Cosine curve looks like this.
Okay, that makes more sense.
Starting where my x is. In other words, it actually curls around a little bit there now. And that's the way you want to graph all of these. Is you want to do your horizontal shift first to find out where you start, add a period to that, break it up into 4 quarters, and go from there. In other words, do it exactly as we did this one. Now, you have to know what the cosine curve looks like and what the sine curve looks like. Because had this been sine instead of cosine, well, I wouldn't have started up here. I would have started right here because sine starts halfway between your high and your low.
Okay.
Okay? All right, let's see.
And then number C, B and C technically.
Okay. It says sketch 2 periods of it. You've sketched about a period and a quarter of it.
Right.
So to get the rest of it, since you ran out of page here, maybe you have room there, but to get
but on
periods, you need to either continue it in this direction or continue it in this direction until you have another trough.
Okay.
Okay, and that would be 2 full periods. C, write an equivalent equation using a sine function. Okay.
How do I do that?
Okay, if I continue this thing like that, in other words, if I draw another period of it, well, this would be a sine function if it starts right there and it was shifted to the left, right? In other words, my sine function looks like this. An unshifted sine function looks like that. Starts on the line of symmetry and goes up.
Okay.
Well, what is this point right there? What is the measurement of it? If my period is 24 and this is 8, and when I say 8, I mean on the x-axis, what is this measurement right here?
Wouldn't that be -4?
Very good. -4. In other words, that's half a period. So it would have to be 12 from there to there. Okay?
Right.
If that's -4 and I wanted to write this as a sine function, everything else is exactly the same. The amplitude is still 6, but if I'm using a sine function, the period is still 24. But instead of -2, I'm moving 4 to the right.
Okay.
In other words, if I gave you this function and said graph it, you would figure out what A, B, the period's still 24, but we would start by moving 4 units to the left and then begin our curve there. Well, if I start by going 4 units to the left, there's my starting spot right there. And I'm starting with a sine because it starts at the line of symmetry and goes up.
Okay.
In other words, every sine function is a phase shift away from being a cosine function. Let's look at both sine and cosine. There's sine, here's cosine. Well, notice that if I extend the cosine to there and shift it to the right by pi over 2, I got the sine curve. So if I want to say y equals sine x, that refers to that curve right there. But I could also say the cosine curve right there, this would be y equal cosine of x. But I could also call this curve y equals sine of x, and it's been shifted left by pi over 2, so plus pi over 2. So my cosine curve could be called sine of x plus pi over 2, or x plus 90 degrees. The sine curve is merely the cosine curve that's been shifted to the left by pi over 2. So every one of these sinusoids can be expressed either way. And the rule is you usually use whichever one results in the least phase shift. Well, when they used cosine for this, they had a phase shift of 2. When we wrote it as sine, we had a phase shift of 4, right? So the correct way to write it is cosine. It's the smallest phase shift, the smaller of the 2 phase shifts. But either one is correct. It would be correct to say sine and then plus 4 instead of minus 2. All right, should we go to another page?
Yeah, let's go to the one with the giant kind of graph on it.
This one?
Yeah, that one. Yeah, you can rotate it.
All right, a word problem.
Yeah. I was just all sorts of confused and making it way harder on myself.
Let's start from the top. The buoy moves a total of 6 feet from its high point to its low point, which makes A what?
6.
No. You take the high point minus the low point and divide by 2. So 6 minus 0 divided by 2 is 3. So you got an A of 3. Remember, A is your amplitude.
Okay, so I was right.
This 3 is correct, but this needs to say 3.
Okay.
Let's see what else it says here. And it returns to its high point every 15 seconds. What is the period?
15 seconds?
Exactly.
Okay, so it wouldn't be 2 pi over 15?
No, it's 15. Now, what is B? Because B relates to the period. Always remember that when you get B, B is 2 pi over the period, which makes the period 2 pi over B. So make sure you know both of those. They're not two different ones. They're the same thing.
Right.
Okay? Well, in this case, we know the period, right?
Right.
15.
Mm-hmm.
there's B.
Okay.
So you kind of got it right. It's just you called it a period instead of B. The period is 15. In other words, you need to erase that and say 15. But B is 2 pi over 15.
Okay. So.
Okay?
So the horizontal shift would be 2 pi over 15.
No, the period is not the horizontal shift. The horizontal shift is completely unrelated to the period. Let's see, hold on a second.
So which one's B?
B is 2 pi divided by the period. The period is 15, so B is 2 pi over 15.
Okay, it just doesn't have it like over on the left-hand side. Okay.
Right. B and the period are not the same numbers. That's why you have to memorize these. B is 2 pi over the period, always.
Okay.
And the period is 2 pi over B. You know, just doing the algebra.
Right, okay.
Okay? So they give us the period when they say it goes back to its high point every 15 seconds. So 15 seconds is the period, but then to get B, you got to do 2 pi divided by the period.
Okay.
Or to get B, rather.
Okay.
You do 2 pi divided by 15, and that's what B is. Okay. Now let's talk about...
That'd be 7.5?
What's that?
That'd be 7.5?
I would leave it as 2 pi over 15. I never convert that.
Okay.
Ever. Okay? Because you only convert them if you can use integers. If you have to break it down into a fraction, like 7.5, in fact, it's pi over 7.5. It's not 7.5 pi. It would be pi over 7.5 if you simplified it. But you would never want to do that, because I've got it in integer format right now, and it's the simplest, lowest form. 2/15 can't be reduced.
Right.
Okay. So let's talk about the horizontal shift. No, let's talk about the vertical shift.
Okay.
Because the vertical shift is the high point plus the low point divided by 2.
Okay.
So the vertical shift is also 3.
Okay.
In other words, if this is my x-axis, I'm going to move my line of symmetry up 3 feet. In other words, I'm going to start my drawing off like this. Because I know that the vertical shift is 3, then I'm just going to start off by moving that line of symmetry up to 3. Now I know that because the amplitude is 6, it goes up 3 more to its high point, and it goes down 3 to its low point. So this thing is going to go back and forth between 0 and 6.
Okay.
Okay? Giving it a vertical shift of 3, or D is 3.
Okay.
So the last thing we need to figure out is the horizontal shift or the phase shift. When no waves are on the surface, the water is at 20 feet. The fact that they say the high point corresponds to a time of 0. Means that if this is my time curve right there, the horizontal curve, and they're saying the high point comes right there, then what kind of curve are we talking about? Sine or cosine?
Cosine?
Right. A non-phase shifted cosine. I don't need to do any horizontal shifts at all to this. because they told me the high point came at time 0, right there. So I'm good to go if I use cosine. How do I get the curve? Y equals A, which is 3, times cosine of B, which is 2 pi over 15, times X minus C, C is 0, plus 3.
Okay.
Okay. Now, so the horizontal shift is 0. C is 0.
Okay.
The only part that I didn't take into account was this part here that says, with no waves on the surface, the water height is at 20 feet. What that means is that, in other words, when there's no waves, it's a flat line, right? Well, the water surface is going to be right here.
Okay.
So that dimension is not 3, it's 20.
Okay.
This is now 23. This is 20, or, excuse me, 17.
Okay.
Now, I'm not sure why they threw that in to confuse you, because that's all it does. Notice our amplitude still, it's 6 feet between the high point of the wave and the low point of the wave. The plus 3 for D really should be a plus 20.
Right. See, that's what was confusing me. I was just like,
No, let's redo this. This is plus 20. In other words, if there's no waves and the height of the water is 20, then our line of symmetry has to go through 20. So it doesn't go through 3. In other words, the bottom wave isn't at 0 feet sea level. It's when there's no waves, the sea is 20 feet high. So when there's waves, the bottom has to be 3 feet less than 20. So this whole curve needs to be moved up 20 feet to get started.
okay.
That's where we really should have started. I didn't think this through enough.
Yeah, it's exactly what I was doing in class. I was like,
All right. So, yeah, if you're going to, and you want to graph 2 periods of it, you know that 2 periods means I've got to have, right now I have 1 peak and I have another peak. I have 1 period of it. So I can graph my second period like that. Now I have 3 peaks, so I have 2 full periods. Okay. And this is 15 seconds. So this has to be 30 seconds.
Okay.
15 seconds between peak to peak of the waves.
Right.
All right. Write 2 equations to model the situation using sine and cosine as a function of time. Okay, well, when we wrote it as a cosine function, there was no phase shift, right?
Right.
So, tell me how I should write this as a sine function.
You should...
Doesn't change the period, so it doesn't change B. But now there's a phase shift in here, question mark. Doesn't change this, D. Nothing changes except the only difference between sine and cosine is that phase shift. Well, go back and look at this curve and extend it to the point where we would normally start a sine curve.
Okay.
How far have I had to move it to the left?
That'd be 15 seconds to the left.
It's 1/4 of 15 seconds.
Oh.
In other words, I only had to move it 1/4 of a period. Right?
Okay.
In other words, from
Right.
peak to trough is a full period. If I had to move it all the way to there, that's a full period, or that's a half a period.
Mm-hmm.
Well, I only had to move it 1/4 of a period. So 15 divided by 4 is what this number is over here, and it's got to be to the left, not the right. So this has got to be plus 15 divided by 4. There's the way to write it as a sine function.
Okay. That makes sense.
Always know that the difference between a cosine and a sine is the sine is always 1/4 of a period moved to the left from cosine. Remember when I had my regular cosine, which looks like this? Well, that has a period of 2 pi. Well, to draw it as a cosine or as a sine curve, this period right there is pi over 2. In other words, I've got to take my cosine curve, I got to take my normal sine curve, which would start here, and move it to the left by pi over 2 in order to get the cosine curve. Well, pi over 2 is 1/4 of this period, 2 pi. So the difference between this being a cosine curve and a sine curve is it's a sine curve that's been phase shifted. This curve is either y equals cosine of x, or it's y equals sine of x plus pi over 2.
Okay.
What is the height of the wave after 20 seconds? Well, that's real easy to answer once you have the function. Remember, x is t. Let's make it say t instead of x. The horizontal axis here is t. We know the height of the water at any t. Okay? At time equals 0, the height of the wave has to be at 23 feet because it's starting at its high point at time equals 0. So when they say, what's the height at 20 seconds, just fill in 20 seconds for t. You got your answer.
It would be, let's see, not yet. It would be at like 19.
Well, here, let's answer this. Y is 3 cosine. If I fill in 20 for t, then I've got 40 pi over 15 plus 20. So the question is what is that number right there?
That is here, cosine of...
You can do that on your calculator directly, I think.
Yeah, I think so. Let's see, 40 pi over 15.
Should be a negative number.
I keep typing in the wrong thing, sorry.
Cosine of, it's the same as cosine of 10 pi over 15. In other words, I can take out a 2 pi away from this thing to get it into the unit circle. And 2 pi...
I got negative 0.5.
Okay, negative 0.5.
Mm-hmm.
So 3 times negative 0.5 is negative 1.5. Add 20, you get 18.5 feet is the height of the wave after 20 seconds.
Okay.
Someplace right about there on my curve. See where I circled? Notice that this is about 20 seconds.
Right.
All right. Notice the first 4 times the water level is at a height of 18 feet. Well, 18 feet is down close to here, right?
Mm-hmm.
So there's one time right there. There's another time right there. There's another time right there. And there's another time right there. So how do I solve the problem? Well, I let y equal 18.
Okay. So
I have to solve this equation. 18 equals 3 cosine of 2 pi over 15t plus 20. So I have to find the first 4 solutions of that are positive. Okay, let me show you how to do that. We're going to take 20 away from both sides, so now we get minus 2 on the left equals 3 cosine of 2 pi over 15t. Now I divide both sides by 3. I get that. Well, now I have to solve this equation. So if the cosine of 2 pi over 15 times t equals minus 2/3, let's take the inverse cosine of both sides. Well, what's the inverse cosine of minus 2/3?
Inverse cosine of negative 2/3 is 2.3.
In radians or seconds?
Let's see. Mine's in radians.
Actually, yeah, you should be in radians. Okay. So what did you get as an answer?
2.3.
Now solve. In other words, what's left when I take the inverse cosine of both sides? You get 2.3 there, and you get whatever's in the argument on the left side. So now t is equal to 2.3 times 15 divided by 2 pi. So that's the first time that the height is equal to 18 feet.
Okay.
Now, once you come up with this first time, whatever number that is, you want to give me a number on that, and then we'll be able to...
Divided by 2 pi. I got 54.19, so 54.2.
2 pi is like 6, so we're taking about 1/3 of 15. Try this again on your calculator. You're going to need to use parentheses around the denominator.
Oh, okay.
So it's 2.3 times 15 divided by parentheses 2 pi in parentheses.
5.4.
Okay, that makes more sense. So if I go back to my picture, that means that's at 5.4 right there.
Ah, okay.
Okay. If that's at 5.4, what is this point right here?
What point? I'm sorry?
The third time that it hits that height. In other words, we've got these 4 times. The first time it hits that height is right there. The second time is here. We're going to get to that in a moment. Then the third time is over here, and the fourth time is here. Well, the one thing I know about the third time is it's exactly 1 period after the first time. So what's this measurement on the x-axis? Remember,
would you add them together and divide by 2?
Start with 5.4 and add 1 period to it. Well, the period is 15.
Oh,
so
right.
This is
Plus
20.4.
20.4.
Okay?
Okay.
Now,
okay.
getting this. Well, I know that that's 7.5, right?
Right.
And I know that this is symmetrical. So I know this point where it's on the rise going up has to be the same distance from 7.5 as the 5.4 is.
So it'd be 2.
2.1 to the right
2.1.
of 7.5 puts it at 9.6. And then finally the fourth period, the fourth time it hits that height is exactly 1 period from 9.6. So I add 15 to that, I got 24.6. So those are your 4 times, 5.4, 9.6, 20.4, and 24.6.
Okay, that makes sense.
That's actually a fairly hard problem to do.
Just a little bit.
Yeah, it is. It is. Just I know we don't.
It kind of all started with how it was worded, technically.
Well, it's any word problem using sinusoid functions are tough. They are. The most important thing you can remember is about a word problem is that A is your maximum minus your minimum divided by 2, and D is your maximum plus your minimum divided by 2.
Okay.
In this problem, our maximum was 23, our minimum was 17. Between top and bottom was 6 feet, and when everything was flat, it was at 20.
Okay, and just to go, the horizontal shift is considered C, right?
Yes, that's called
And then,
phase shift, yes.
Okay, and
Now,
on
hold
this,
on, I better restate that, because it kind of depends on what your formula is. In other words, there's 2 ways to put B. I can do this.
Okay.
I'll give you an example of both ways. If I give you this formula, the phase shift is pi over 2, which is also C. But if I should write that, I might write that like this. Same function, same exact thing. But this time, C is pi. In other words, in order for C to be the phase shift, you've got to get B outside of the parentheses. I've got to, if I start here, I've got to factor that 2 out so that I take it outside the parentheses. Well, I'm still left with x there, but now I got pi over 2 there. Now I can say that is the phase shift.
Okay.
It depends on whether B is inside or outside the parentheses. Now, on one of these problems that you gave me here, it was outside the parentheses. This pi over 2, notice that they got a double set of parentheses, okay?
Mm-hmm.
But it's outside of the parentheses containing the x and the c. That's what's important. In other words, the way they've expressed this here, 2 is your phase shift. I don't have to take this pi over 12 outside of the second set of parentheses. In fact, this second set of parentheses isn't even needed. I don't need this parentheses right here. If I erase those, I've got the same function. Exactly. They're put in there only for clarification. And they confuse more than they clarify. So I wouldn't have put them in. But. All right. Aaron, I got a 7 o'clock I got to go to, so I'm going to have to run.
All right. Well, thank you so much.
You're welcome. I'll talk to you next Monday.
Sounds good. Have a good week.
You too.